A few months into your career in big tech, you're going to be asked to move on from delivering small features like methods and other small bug fixes to delivering large-scale systems designs. College teaches you a lot about writing clean code and working with the team using Git, but it doesn't teach you about using cloud tools and authoring large enterprise-level systems on the cloud that are built to scale and last. I joined Amazon as a software engineer almost 2 years ago now, so now I want to give back and share the tips I learned to get through all the firsts in big tech that were pretty challenging. If this feels valuable to you, you might want to check out my channel and follow for more. Now, before you go about authoring any systems design, it is critical that you understand the exact requirements that you're attempting to deliver and you know exactly what problem you're going to solve. There are two types of requirements you need to consider: functional requirements and non-functional requirements. Functional requirements might look something like a user is able to log into their account and see a certain home screen, and within that home screen manage their files. A non-functional requirement might be something like my system is available 99.99% of the time and users can log in within 2 seconds. Understanding both of these requirements is critical for an excellent systems design, as nobody's going to want to use your product if it doesn't deliver the base requirements, but everyone's going to click away from your website if it takes longer than 3 seconds to load. In big tech, these requirements are often given to you a lot of the time if you speak to the right people. Your project might have a product manager, a technical program manager, or even just the manager of your team that can help you clarify the scope of your project. If you don't have that, you should try to speak to customers and gather feedback from the people that you're actually designing for to see what exactly they want. But don't let them dictate your design to you. Just let them tell you what they want, and you as a software engineer will come up with the best way to deliver upon those requirements. Now let's get into the more technical components. When you're selecting exactly what tools you're going to be using for your systems design, you need to justify exactly why you're using each one and how come that is the right choice for this situation. Some common examples of this might be, why are you using SQL or NoSQL? Do you have an event-driven architecture, or are you polling? There's valid use cases for both of these things. You just need to make sure you justify exactly why you're doing what you're doing. And even within NoSQL, are you using MongoDB or are you using DynamoDB? Are you hosting your own server? Here's what a simple justification might look like. I would like to use an event-driven architecture, but I have to use polling because I don't have control over the clients and they don't provide me any way to do an event-driven architecture like a webhook. Therefore, I have to make repeated calls to their API to see if there's any updates to their website. Within this part of your design, you also need to consider what you're doing and what you're not doing. Let's say your service is only expecting to get 5 calls per day. You probably don't need caching. You probably don't need insane scaling and TPS. You really just want your service to be as simple as possible in this case and deliver exactly what the customers want with the lowest possible cost to the company. But now let's say you're expecting 500 million calls per day and they're all going to be requesting the same data. Well, in that case, you almost certainly want to introduce a cache because you don't want to make all those requests to your database when they're just asking for the same data over and over again. So you should really consider exactly what you need to deliver and what you don't need to deliver. Do not over-engineer your design if you don't have to. Working on simple systems is best for both engineers in the future and customers. Now, my next piece of advice is to think about scaling early on. On my team, we've inherited a lot of legacy services that really weren't built to scale to the use cases that we're now using them for, and this has caused us a ton of pain. It is so much easier to make a scalable design up front than it is to go back in time and fix a design that has hundreds of customers on it. So at the very beginning, your design should address concepts like, is this system meant to scale horizontally or vertically? What exact types of data is this database meant to store? And what are the current limits of the system the way you've designed it? Let's say your service can only ever handle up to 1,000 transactions per second with the current configuration. That needs to be explicitly called out within your document, so when you hit that failure case, no one is blaming you, and you can just point to your document and say, hey, I said this would fail. This is the limit of my system as it currently exists. You should also consider other limits like, hey, I'm using Lambda and API Gateway, therefore I cannot handle anything larger than a 6 megabyte payload. If we want payloads bigger than that, we should consider an alternative design here, like pre-signed S3 URLs. Now, while scaling is important, we also need to talk about fault tolerance and reliability. Depending on what type of system you're working on, these could be the most important things, and they could be more important than latency or scalability, depending on your company's priorities. Make sure you are extremely familiar with both the CAP theorem and the PAC-ELK theorem. I'll link some documentation to both of those down below, but they are incredibly important to understand, and they can really power all these trade-offs you're making throughout your design. If you do want to design more for fault tolerance and availability over something like latency and consistency, then you need to consider that from day one. What happens if one AWS region goes down or part of your database goes down? What's your strategy for consensus? How are you going to handle all these things? A lot of cloud services can handle this for you. For example, if you're using DynamoDB, you can simply have a global table, meaning if one region goes down, your data will still be stored in a second globalized region. But if your service isn't deployed to multiple regions, well, you're not going to be able to access it via your APIs. Maybe this is okay and you have some manual fallback strategy. I never recommend this, but it is something that you could consider. If you do really care about availability, it's best to build that into your system's design from the get-go and not have some sort of manual fallback strategy. For example, your system should be completely deployed into 2 AWS regions instead of having it mostly deployed in one and one backup of your database where you can manually fetch the data in the event of an emergency. Okay, so now we're at a place where we've identified the components, identified the use cases. Now we want to make sure that the performance of your system is optimal. In big tech, systems often must handle insane scale and deliver fast, reliable responses, and these are some of the considerations that you need to consider for this. Number one is identifying the performance bottlenecks where your system actually could have a problem. These could be latency sensitive paths, you could have heavy dependencies, and you could have database hot partition keys. If you do have things like heavy computations, consider offloading that to an async call or something like an SQS queue to handle those at a slower time pace. Caching is one of your best friends for speeding up your system. If you have read heavy systems, you get a lot of the same calls, so you pretty much have to implement caching to ensure great performance. You can also do caching within your application and store the results of calls to external services that you don't expect to change or you don't care about having eventually consistent data. Just make sure you watch out for stale cache data, as this can introduce a lot of really nasty bugs that are pretty difficult to solve. You should also consider asynchronous processing when possible. If it's data that you don't need immediately, send it off to an async job. This will speed up your system vastly and you won't be depending as much on these long calls. Databases are often a bottleneck within your system. Make sure you've optimized your database for the access patterns that you're expecting. No matter what database you're using, there's different strategies you can use, like having a different partition key to speed up the database access. And you can even use strategies like denormalization or duplicating the same data in multiple parts of your database to speed up queries when necessary. You should also consider if your system needs to work with large amounts of data, how are you going to handle that? Are you going to use something like pagination on your API calls to reduce the amount of data you have to send with each request? Or are you going to try to compress that data or send it through S3 or some other mechanism? Now, let's talk a little bit about the security of your system. Your system needs to be designed with security in mind from the beginning. In big tech, there's usually a lot of resources that can help you make sure your system is secure and will not let you release your system unless it is. Some easy ways to implement security on your system is make sure that users cannot access it unless they're authenticated with some certain credentials or you've explicitly granted them access through some service like Amazon IAM. Now, you also need to consider that people might try to use your service in ways that you didn't expect, and you need to account for this. A simple way to do this is by putting throttling on your users. If somebody makes 1,000 parallel requests to your service within the same second, there is a decent chance that this could take down your service or at least have some unexpected side effects. To do this, you can implement something called throttling on your customers, basically meaning say, hey, if this person tries to make more than 100 requests to my service within 1 second, cut them off. They can only have 100 calls to my service available at any time. Any limitations like this should be stated within your design document and clearly communicated to any customers up front. If a customer does try to violate this agreement and send you too many requests, you can just send them a 429 exception or too many requests. So you've designed your entire system and now it's time to take it to review with your team and possibly senior leadership. There's a couple things that you need to make sure you're ready to talk about going into this meeting. Some of the things that should be right at the top of the document are: 1, what is the purpose of this systems design and what exactly does it solve for? You should also include exactly what it does not solve for. People love to come into systems design meetings and say, oh, hey, I'm working on this next year. Does this solve for that? If your design does not explicitly solve for that, tell them no, we are not doing that. There's a very real problem with systems designs in big tech called scope creep. This is basically when additional requirements keep piling onto your design and it ends up being so many requests that you can't possibly deliver something to meet them all. Nobody's going to have a problem if you say, nope, I've designed my system for this and that's what it's going to do. If you want that feature, that's going to be a different design and a different service. You should be able to rely on your management and product team to help defend the scope of your project. Remember, everybody on the projects wants you to be able to deliver a complete project that addresses all of the initial requirements. If initial requirements keep piling on, it's just not going to be possible as there's only so long you have to work on this project. Now next you want to include a simple visual diagram that highlights all the components you're going to be using. I like using Lucidchart for systems design on my own time, but a lot of big tech companies have their own internal tools for making designs like this. Whatever your team is currently using, I would just use that. Design should make it absolutely clear what the experience is like both working with your app and what happens on the back-end technical side. I like to start all my systems designs with one user and explain exactly how they're interacting with my system. 95% of the time, this is a user making a call to some API. If you've made significant trade-off decisions like choosing SQL over no SQL or vice versa, you need to justify why exactly you did that within your design doc. Even if 95% of people agree that you've made all the right decisions, if you don't justify why you made them, somebody in that meeting is going to say, hey, why didn't you do this? And then you have to come up with this justification on the fly. So it's better to just address all those concerns ahead of time. You want to anticipate any question that might be coming in and answer it in your design doc. At the same time, you don't want to be overly verbose with your design doc. I do not want to read 10 pages of crap for a simple CRUD API, which everybody has seen 100 times. So keep your design doc as simple and short as possible. Only answer the questions around big trade-offs and large-scale decisions, because that's what everybody's going to care about. You should also include a loose cost breakdown of what your service is going to cost the company. company? Are you using internal tools? Are you using external cloud services? And why did you make the decisions around those tools? Was there a cheaper option? Did you feel like the price of that service was worth justifying the performance you're going to get from it? All these are valid questions, and people might ask about why you made certain decisions and how much that's going to cost the company. Here are the key takeaways. Understand the requirements of your systems design and avoid scope creep. Avoid over-engineering. Start simple, but design for scalability in the future. Answer common questions before they come into your design doc and highlight key trade-offs around why you made certain decisions. If you found this video helpful and you want more advice for new engineers in big tech like yourself, check out my channel and subscribe for more. See you guys next time.